In this lesson, we will use Desmos.com to explore the equations of circles in the forms r equals n sine theta, and r equals n cosine theta. In the polar coordinate system, points are given in the form r comma theta, where when r is greater than 0, a point given in polar coordinates lies along the terminal side of angle theta in standard position r units from the pole. Polar equations are expressed using r and theta. Let's begin by going to Desmos.com and clicking Graphing Calculator. In cell 1, let's enter r equals 5. Notice how this gives us a circle centered at the origin with a radius of 5. From here, if we click enter, we now have a slider so we can change the value of r. Notice regardless of the value of r, the circle is centered at the origin, and the radius of the circle is equal to the absolute value of r. Now if we want, we can click on the wrench in the upper right hand corner, change the grid to polar form by clicking on the polar graph. We also have the option of radians or degrees. Let's use degree mode. Let's close this menu by clicking outside the menu. Let's go ahead and turn off this circle by clicking on the red circle to the left of the equation. Let's go to cell 2 and let's enter r equals n sine, open parenthesis, theta, which from the computer keypad, we type in theta, close parenthesis. We can also find theta on the Desmos keypad by clicking on the Show Keypad button, clicking on the ABC button, and theta is on the far right here. Let's close this keypad. Notice we have an option to add a slider for n. Let's click the n to add a slider. Notice by default, the interval for theta is from 0 to 180 degrees, which you can see from the graph does give us a complete circle, where the diameter is along the vertical axis. Notice we can change n from -10 to +10. If we click on the upper or lower bound for n, let's change the step to 0.5. Click outside of cell 3, and now we can use the slider to change the value of n. Notice when n is positive, the diameter of the circle is along the positive y-axis or vertical axis, and when n is negative, the diameter is along the negative y-axis or negative vertical axis. Also notice how if we stop at, let's say, n equals 6, the absolute value of n gives us the diameter of the circle. Remember, in the first equation, in the form r equals n, the absolute value of n gave us the radius of the circle. Let's go ahead and turn this equation off by clicking on the blue circle to the left of the equation, go down to cell 4, and let's enter r equals n cosine theta. Notice this form of a polar equation gives us a circle as well, but now the diameter is along the x or horizontal axis. So when n is positive, the diameter is along the positive x or horizontal axis, and when n is negative, the diameter is along the negative x or negative horizontal axis. But once again, the absolute value of n does give us the diameter of the circle. Now let's go ahead and change n back to, let's say, 6. There is one more thing we might want to explore. We might want to see how the circle is traced out as theta increases from 0 to 180 degrees. To do this, let's first change this circle to a dashed orange circle by clicking and holding on the purple circle on the left. Click on the dashed style and the orange color, and then click outside the menu. And now we're going to duplicate this equation by clicking on the gear toward the top and then clicking the duplicate option, which is to the right of the equation. Now let's go ahead and scroll down here. What we're going to do is limit the domain for the second equation for theta from 0 to a, then create a slider for a. So let's click to the right of the equation, open squiggly bracket 0, and now let's go to the math keypad, enter less than or equal to theta. Using the Desmos keypad, click the ABC button, and then the theta key, back to the number keypad, less than or equal to A from the letter keypad. Notice how we have an option to add a slider for A. Let's do that. Next, we want to change the color of the graph in cell 5. So let's click and hold the orange circle on the left. Let's change it back to solid, and let's select the color purple. Exit from this menu, and now we'll change the values of A from 0 to 180 degrees. Click the -10, enter 0, tab, 180, tab. Let's have a step of 5 degrees. And let's go back and click in cell 5, close the keypad, and now we can change the value of A, which is the angle of theta, and see how the circle is traced out from 0 to 180 degrees. Notice from 0 to 90 degrees, we get the top half of the circle in the counterclockwise direction. And then from 90 to 180 degrees, we get the lower half of the circle. Notice how the graph just turned lighter. If I want it to be darker like it was before, I need to click in cell 5 again, and then go back to the slider. So using this trace feature is a nice way to determine how the graph is traced out over a specific interval for the angle theta. Let's go back and summarize our findings. A polar equation in the form r equals n is a circle with a radius absolute value of n centered at the origin. If we have the polar equation r equals n sine theta, we have a circle where the diameter is equal to the absolute value of n. When n is greater than 0, the diameter is along the positive y-axis. When n is less than 0, the diameter is along the negative y-axis. When we have an equation in the form r equals n cosine theta, we have a circle with a diameter, absolute value of n. If n is greater than 0, the diameter is along the positive x-axis. When n is less than 0, the diameter is along the negative x-axis. I hope you found this helpful.